Welcome to video 4. Today we're going to look at solving quadratics by completing the square, more of a specific step-by-step method that you can use to help go through the steps of completing the square. But remember, we can also have our picture that we just talked about in the previous video to represent completing the square. Before we get into completing the square, we're going to talk about why x squared plus 8x plus 16 is an example of a perfect square trinomial. So the hint here was to factor it. So to start off, we're going to factor it. So in order to do that, I'm going to start with the x and then the box to go ahead and factor. Okay, so I've drawn my x and my box. Remember, at the top I put a times c, and at the bottom we put b. So the first thing I'm going to do is write down what a, b, and c are. A is 1, B is 8, C is 16. So at the top I'm going to put 16, at the bottom I'm going to put 8. So when we think of the factors of 16, we go through 1 and 16 doesn't work, 2 and 8 doesn't work, 4 and 4, that will work. 4 times 4 is 16, and 4 plus 4 is 8. Now I can go over and fill in my box. So I'm going to rewrite this first trinomial as 4 terms so that I can do factor by grouping. So x squared plus the 4x and the 4x plus 16. Then remember to group the first two and then the second two. Then we put the first two in the top row and then the second two in the second row. And then factor out the GCF of the top, it would be x. And then fill in the missing one. So what times x would give me x squared? That would be an x up top. What times x would give me 4x? That would be a 4. What times x would give me 4x here? That would be a 4. And then always check that last one. 4 times 4 is 16. So now I can write this as the x plus 4 and x plus 4. Oh, but x plus 4 times x plus 4, that's the same thing as just writing x plus 4 squared, like we did yesterday. So these, when we factor, we see that this question was special because it came out to be the same factor times itself, so we can write it as that factor squared. So the question was, why is it an example of a perfect square trinomial? Well, it's because when we looked at the factors that we got, it was times itself. So it made it special kind of quadratic that we'll look more at when we go into solving equations by completing the square. We're trying to create a situation where we have the same number on both sides of the square, completing the square to get a perfect square trinomial. Okay, so let's look at the steps for how we can complete the square. Okay, so our first step here is to rearrange the equation so we can get the variables on the left-hand side and the constant on the other. So remember that we get the variables together so that we can manipulate them into completing a square. So first I'm going to subtract 14 to the other side. Now, in the previous lesson, I just added the blank right away, which you can still do, but sometimes there will be situations where we have to do something first before I can go ahead and complete the square. So that's this step number 2. Check the a value. If the a is greater than 1, we need to factor out the number only. And the reason for this is we have 2x squareds. So I would have to complete 2 squares at the same time. And that just kind of gets messy. We don't need to, because what I can do is divide out that 2. So I'm going to divide all 3 terms by that 2 so that we can get an a value that's only 1. So I can only complete 1 square. Now, since I have an equation, that's why I'm going to divide all the terms by 2. Otherwise, I could just rearrange it and put it out front on this hand side, but I can really just divide all 3, and then that'll stay equal because I've done it to everything in the equation. Once I've divided all of the terms by 2, I end up with the x squared minus 6x equals negative 7. You can choose to add the filler space in at that point or add it in afterwards as a second step. Okay, so at this point you can go ahead and draw the square if you would like to figure out how many I would need to add to both sides. You can use that space down below to do that. So we would draw a square to represent the x squared, and then 6 groups of, remember that they're negatives, negative 6x. So that would mean I need to put negative 3 on each side of my square. How many would I need to add then to complete the square? And the answer would be 9. So I'm going to add 9 to both sides. So the whole point of this on the left-hand side is to rewrite this as a binomial squared. So think to yourself, what is the new side of the square? Well, it was an x. Then I had -6, so I had to put -3 on each side. So the new side of the square is x minus 3. And that equals 2 because -7 plus 9 is 2. Okay, next step. We need to get x by itself. So the first thing I need to do is take the square root of each side to get rid of the squared. So now that becomes x minus 3 equals plus or minus radical 2. Then to get x by itself, add 3 to both sides. So then my answer is x equals 3 plus or minus radical 2. And remember, this means that we have two answers. One is 3 plus radical 2, and the other is 3 minus radical 2. And also note that I couldn't simplify the radical 2 since there are no perfect squares that go into radical 2 to make it any smaller. Okay, so we completed the square based on the information I gave you in the last video. Now, these are steps over here that you can follow instead. After we added the filler space, remembering that we need to add to both sides, we then complete the square. We do it by actually thinking of how we can complete the square as an image. These are the procedures, the step that you could just follow if you memorize them. Now, again, this would be something you'd have to memorize, or you can just use the method of actually completing the square to help you identify what needs to be done. So identify the B number. So in our case, it was the -6. Take half of it. That's where we put half on each side. So that's the -3 on each side. And then square it. So -3 times -3 was 9. Add it to both sides. So that's the plus 9. Then we need to manipulate the expression with the variables to write it as a binomial squared by, we can think of the box that was created and identify the new side length of the square. We can also just take half of b since that is the new side of the square. And then once we've done that, we will square root both sides because that's the opposite of squared or inverse of squared. Put the plus minus on the right in front of the radical term, and that's because remember we take the square root and it can be positive or negative. Simplify when possible, add or subtract to solve for x.